Continue. Okay.
Yes, sir.
How we did yesterday. We did this question. This was the last question we did yesterday. And Betsy, do you have any problem understanding this question?
Sir? No, sir.
Okay. How are you? Enoch, are you there? Okay, let's move on to the next example. I'm coming. Just give me some minutes. I want to open the door or something. Who is that?
Yes, sir.
After. When you say by this, I was my love. Don't you like us, follow? Don't you like us, follow? But you're last. So, look at you. But let me back you.
And it's still like that.
Hello? Hello?
Hello, sir.
Okay. This is the next question.
Hello, sir.
Yeah. How are you? This is the next question.
Fine, sir.
If an object of mass m, physics, if you have done this before, you should be familiar with this question. If an object of mass m is moving at a speed v, the object's kinetic energy, Ke is given by the equation Ke equals to half mv squared. If the mass of the object is halved, that means if the mass of this object is halved and its speed is doubled, how does the kinetic energy change? First of all, without even calculating it, kinetic energy is the energy that is for energy that talks about movement, how something moved. And we all know in physics that the mass is acting like an resistance to that force. Because when there is higher load, just look at it normally. Somebody that has big weight or big body and somebody that has a slim body. Among the two of them, who do you think when they run, who will be faster? The person that has a light body should move faster because it has a light weight compared to somebody that has a big weight. So they said if the mass is halved and the speed is doubled, what will happen? Option A, the kinetic energy we have. I think the kinetic energy we have will not be the right answer because since the weight is reducing and the speed is increasing, it means the kinetic energy should increase. That's just the meaning of it. And they said that the mass is halved and the speed is halved, is doubled too. So the kinetic energy, because it's the energy that works with movement, double too. So the kinetic energy, because it's the energy that works with movement, cannot be correct. Option B, the kinetic energy is cannot be correct. Option B, the kinetic energy. So the kinetic energy can never be unchanged because we already told you about the mass that has been reduced and the speed that has been doubled. We look at option C, the kinetic energy is doubled. That makes sense because since the mass has been halved, that makes sense because and the speed has been doubled, it means that there should be an increase in the kinetic energy. Now, the last option D, kinetic energy is quadrupled multiplied by a factor of 4. It means that the kinetic energy is increased in 4 with a factor of 4. But the option is between C and D. But let's check the solution. That will point us to the right direction. If the mass of the object is halved, the new mass will be m over 2. I mean, this m here will be m over 2. And if the speed of the object is doubled, the new speed will be 2v. So your formula for kinetic energy is half mv squared. So substitute with the value of your m and the value of your v in the equation. That will give you the answer. So half is your m, your new m over 2 times 2v squared. So when you do that, you have 4v squared. So you have mv squared. And you solve it. No, we have to cancel out some stuff. So you end up getting mv squared. Now, this is your kinetic energy now. This is your kinetic energy before. So your half mv squared and mv squared. It means that the kinetic energy has been doubled because half mv squared, half is like, this is more like the double of this, or the kinetic energy here is half of this. So since you have mv squared here, this is like 1. Half mv squared is just like half. So it means that it has been doubled if you look at it. So if you multiply this by 2, you're going to get mv squared, which means it has been doubled. So the answer should be C. Do you understand?
Yes, sir.
Enoch, do you understand? I'm coming. Here's another example. Example 10. A gas in the container will escape through holes of microscope size as long as the holes are larger than a gas molecule. This process is called effusion. If a gas molecular mass M1 effuses at the rate of R1 and a gas of molecular mass M2 effuses at the rate of R2, then the following relationship holds. R1 over R2 equals to root M2 over M1. This is a formula that is given in your physics textbook too. So this is known as Gram's law. Which of the following correctly expresses M2 in terms of M1, R1, and R2? It's a very simple question. You're just asking for you to look for the subject of the formula. So if you rearrange it, if you arrange this thing very well, R1 over R2 equals to root M2 over M1. So for you to remove this root, square both sides. That will give you R1 over R2 all square equals to root M2 over M1 all square. So when you root square both sides, so these roots, you cancel the square. So you should give you M2 over M1 equals to R2. You just interchange it. So this one is R1 over R2 is equals to M2 over M1 since this root has been removed. So multiply both sides since we are looking for our M2. So you cross multiply or you multiply both sides by M1, either of the two. Multiply each side by this side by M1, which give you, when you multiply that M1 by both sides, M1 will cancel M1, and it's now be M1 into R square over R1 square over R2 square. That'll give you option A. This is just like arranging for the solid of the formula. It's very, very straightforward. Do you understand?
Yes, sir.
Yes, sir.
This is like the question we did yesterday regarding vertex. Remember, I gave you some equation yesterday that how to know the difference between intercept form and vertex form. And what we did yesterday, we did the example of intercept. So the next example we want to do now is for vertex form. And this is it. Now, a store manager estimates that if a video game is sold at a price of P dollars, the store will have weekly revenue in dollars of RP equals to minus 4P squared plus 200P. You look at this, look like this is a quadratic equation. Now I told you yesterday that when you're talking about intercept form and vertex form, they are going to be talking about quadratic equation. From the sale of the video game, which of the following equation form of RP shows as constant or coefficient? The minimum possible weekly revenue and the price and the result in the maximum revenue. Now, Betty,
Yes,
Betty,
sir.
they're asking for the maximum possible value weekly. When they're asking for vertex, I told you that either they're asking for the maximum value or the minimum value. Or sometimes they will just ask you that the vertex. You can tell you to look for the vertex or something, or they will ask for the minimum or maximum value. Now, I don't know how I can use it to do. I think I will still get some question that shows I'm trying to look if I can get something that I can explain. For example, if you have this is W, but let's say we have a U inside of W, you have a U like this.
Yes,
A
sir.
U come down like that, facing up. The lowest point is the vertex. If it's the opposite, like up like this, the lowest point, the base of that shape is called the vertex. So I'm just showing you the diagram representation of it now. But if they ask you that, even without calculating this question, and they're asking you to look for the minimum or the vertex, which option will you pick between A to D without even calculating it?
It should be D because of the format in which it's presented.
Yes.
Because vertex is always in graph
What's
format.
the document?
So it will be D because, and when I ask for, like I told you, they're looking for the minimum value or the maximum value. They are still asking for vertex. So the answer is D, even without calculating it. Now, but there is a way to solve it actually. Way to solve it. Do you know understand what I'm talking about? You cannot. I don't think you can understand because you were not here yesterday. Do you understand what I'm saying?
Not really.
Now, what I told them yesterday, if an equation is given unto you, this is the intercept form. It looks like this: x plus h, x minus k. It will be in this format. If it's vertex form, the axis form, it will be in this format: x minus h all square plus k. That was what I was asking now.
Yes.
If you ask her, if you look at it, the question we just did now has this format.
Yes, sir.
That's why it's the answer. But if it's intercept form, it's going to look like this. This question asks for intercept. So it's going to be like x plus 4, x minus 5, or either A or B, if it's in vertex. So depending on the way you arrange it or you organize it, that will give you your right A or B. But this is how it looks like. For the vertex, this is how it looks like. So that is why I was explaining to him, that even without solving this calculation, this one look for this is This gives a format of the vertex. And that solution I gave
Yes,
option
sir.
is the answer based on the format I told you earlier. So if you use the computing the square method to solve the equation, you will still arrive at the same answer. So there's a way to actually solve it and get the answer. It's but since it's SAT question, you might not have the time to do all of that. If you already know what you are looking for, just because. So let
Sir,
me. What are you saying?
you said they want to ask us the vertex. There was maximum or the minimum to find the other one. What would they ask us to find?
You just ask for the intercept normally.
Okay,
Look at it,
just intercept rate.
the graph of which even that one I said the maximum minimum value, they can still ask for the vertex. And what is the vertex? Or sometimes instead of asking for the vertex, they can just say what's the minimum value, what is the maximum value. But for
Okay,
this
sir.
intercept, they will tell you that they will ask for the intercept. The graph of which of the following is ask X intercept, they will ask for it. So this one, the way we got this one was like, this is a solution of your quadratic equation. So X equals to -4 or X equals to 5. When it goes to the other side, you arrange it. When this one goes to the other side, it becomes positive. That will be X plus 4. This one goes to the other side, we go negative, that's X minus 5. So that's how we got this one. And the answer is actually A. But we were not here yesterday, Sha. But I think Blessing, let's understand.
Sorry, sir. I have another question, sir.
Okay, sir. Ask.
Yes. I read in the textbook that under functions that f of x means the y-intercept. But in this question, they ask for x-intercept.
Y-intercept is usually, when you have a formula, you know your y-intercept now.
Yes, explain me.
When you have an equation. But I'm trying to tell you some pattern of question. They used to ask this type of question in SAT. You ask you to write in the intercept form. And that time when they're asking for is not y-intercept, they're asking for the x.
Okay, sir. Yes, sir.
That is why it has to be like this. You just have to keep that in your mind.
Okay, sir.
So let me show you how to use completing the square to solve a quadratic equation that will help you to get the vertex form of any quadratic equation. Now, this is the equation that we wrote down. RP equals to -4p squared plus 24p, right? This is the equation.
Yes, sir.
Yes, sir.
Now, if you want to solve for using completing the square, you must make sure that the coefficient of p square is 1, Abi. That's
Yes,
the
close.
first.
Yes, sir.
The coefficient of the one that is carrying the square must have to be 1. So that's why we have to divide through by -4. Through all the equation by minus. So that's why when we did that, r into p minus 4 equals to p square minus 50p. So this is the format now. The next step after that is to add half square, the coefficient of p, to both sides. So half square, so the half of 50 is 25, and you square it, you add it to both sides of the equation. When you do that, so sorry, it's not 25, it's minus 25. That's because we have minus 50 here. That's the coefficient of p. It's minus 50. So the half of minus 50 is minus 25. So that will be minus 25 square, right? You add it to both sides. So you see minus 25 square to this side, you add this to this other side too. Now, what you now do after that is that when you have that, what you do after that is this. You come back to this side of the equation. This side is not affected. Come back to this side of the equation, and you look for those that are having square alone. Forget about this middle number. You bring them together. This p square and minus 25 square. Since they both are square, bring them together. So you now have p minus 25 in the same bracket, all square, because they both have square. So you bring them together, more like you are factorizing it. So that's the logic. When you have that, And this other part is still there. This other part is still there. So that part is still there. So you want to bring this other part, you transfer it to the other side. This other part, transfer it to the other side. That will be p minus 25 square. And this one is going back to this other side. Actually, I jumped a step. Minus 25 square is what? That's going to give you 6 to
6 to 5.
plus 6 to 5. So when you bring that plus 6 to 5, you take it to the other side, it's going to be minus 6 to 5. So that's how we are. So can you see that this is already in the intercept vertex form? But we have to
Yes, sir.
balance it because we still have our minus 4 there. So what you do is multiply through by all the equation by minus 4. So when you multiply through by minus 4, you have your RP is equals to minus 4, open bracket p minus 25 square plus, no, we have minus 6 to 5 here. So minus 4 times minus 6 to 5. That will give you plus 2,500. So that is the format. And if you look at it, the same as if you look at this, it's the same as what we got here. I'm coming. Which is the option D. Now, another thing I want to show you is this. The vertex form has a coordinate, which is the lowest point of a graph when you have a U like that. So this 25 for the X, because this represents X value. This one represents the Y value. You see, we still have it on the line. R of P is representing Y. This is going to be the Y intercept because it's C, or the initial value I used to tell you. Now, so that's for your coordinate Y, 2,500. For the X, it's going to be 25, not minus 25, because there's this X comma K. So they can ask you, look at this when I told you. This one. So this coordinates will be for this one, the coordinates for vertex will now be what? H comma K. That's what we did there. So if they give you, so they ask you to look for your H or K. We have your vertex already, just bring them out. You understand?
Yes.
So I will appreciate if you are jotting all these things down because a lot of information is circulating around them. So that is how we have that. Do you understand, please?
Yes, sir.
So I don't understand why it is not the X is not minus 25. Why it is 25?
The formula. The formula.
Okay, sir.
If it's 25 here, if it's plus 25, that's there.
Yes.
The value here will be minus 25.
Yes, sir.
This is how it is.
Okay.
You know the formula? We have, let me go and make the formula so that you see. Let's say we have, here's the formula.
Yes.
Here's the formula. Now, if you are asked to look for 25, no, this is the same thing as this, Abby. It's the same pattern.
Yes.
So sorry, don't let me use this one. Let me use this one. Hmm?
Yes, sir.
I hope I'm not missing it though. I think I make mistake. Oh.
The minus 4 meant to affect um
I'm trying to,
the 25
no, it will not. I don't think it will affect it
minus
because
25.
I don't think it should affect it actually because we already have a pattern we are looking for, and this is just like a coefficient. Now, what I'm saying is this: just focus on this. This is more like you equate this one and this one together. That will be minus 25 is equals to minus h. I mean, compare this one and this one together. Divide both side by minus. That will give you what? So h will be equals to 25. That's why it's that way.
Okay.
And this one, k, is the same as 2,500. Now imagine if this one is positive, if it's not negative, if it's not, then we have minus 25. So that would be 25. Let's say we have plus 25 instead. Don't want to touch it. Let's just have it in your mind. Let's say we have plus 25 instead of minus 25 here. You are going to divide both sides by negative to make sure you divide both sides by negative. This will be minus 20. That would be minus 25 because minus h is equals to 25. Do you understand?
Yes, sir.
But you don't need to be going through all those steps. Just know that this place, oh, if you are asked to look for the value of h, you just bring this value out, 25, and this value for k. That was the need to know. You don't need to do any calculation. I'm just showing you so that you can understand better.
Yes.
But they won't ask you that. What they mostly ask in SAT is the pattern, the way it looks like. So let me start another link so that we can continue with our class.
Okay.